What if we told you that Jupiter could hold over 1,300 Earths inside it? We'll be diving into the latest research from scientists that reveals some of the most intriguing mysteries surrounding Jupiter's composition, atmosphere, and gravitational pull, and what they could mean for the future of space exploration. By uncovering the enigmatic nature of Jupiter, scientists hope to better understand the evolution of our solar system and potentially unlock secrets that could help us better understand the origins of life itself. Jupiter is a fascinating planet that has intrigued scientists and astronomers for centuries. With its massive size and unique composition, Jupiter stands out in the solar system as one of the most interesting and important celestial bodies. Jupiter's immense size is one of its most striking features. With a diameter of over 86,000 miles, which is 139,822 kilometers, Jupiter is the largest planet in our solar system. To put this into perspective, Jupiter is more than 11 times larger than Earth in terms of diameter. Jupiter is also incredibly massive, with a total mass that is 318 times greater than Earth. This makes Jupiter more massive than all the other planets in the solar system combined. Despite its size, Jupiter cannot become a star. Stars are formed from giant clouds of gas and dust called nebulae. These clouds are primarily composed of hydrogen gas, which is the fuel that powers the fusion reactions that occur at the core of stars. In order for a cloud of gas to become a star, it must undergo a process called gravitational collapse. As gravity pulls the gas in the cloud together, the pressure and temperature at the center of the cloud increase. At the core of the cloud, hydrogen atoms will fuse together to form helium if the conditions are right, releasing enormous amounts of energy. This energy is what causes stars to shine brightly and emit heat and light. The more mass a star has, the greater the pressure and temperature at its core, and the more fusion reactions can occur. This leads to a more intense release of energy, resulting in a brighter and more powerful star. Jupiter's inability to become a star is due to the process of star formation. The atmosphere of Jupiter is mainly composed of hydrogen and helium, with smaller amounts of methane, ammonia, and water vapor. The planet's upper atmosphere is characterized by colorful cloud bands, including a well-known Great Red Spot, which is a massive storm system that has been raging for at least 350 years. Below the cloud tops, Jupiter's interior is believed to consist of dense materials, including rock, metal, and hydrogen compounds. The core of Jupiter is about 45 times heavier than Earth. Jupiter is also known for its extensive system of moons. Scientists have discovered 79 moons orbiting the planet, although only a few of them are large enough to be considered significant. The four largest moons are known as the Galilean moons, named after the astronomer Galileo Galilei, who first observed them in 1610 using a telescope. Among these moons are Io, Europa, Ganymede, and Callisto, which are among the planet's largest objects, with Ganymede the largest. The Galilean moons are fascinating objects that have been the subject of extensive study. Io, the innermost of the four moons, is the most volcanically active object in the solar system, with over 400 active volcanoes. Europa is believed to have a subsurface ocean of liquid water, making it a target for astrobiology research. Ganymede is the largest moon in the solar system, has its own magnetic field, and a complex geology. Callisto is the most heavily cratered object in the solar system, and is believed to be one of the oldest objects in the solar system. Jupiter has been a subject of fascination for astronomers for centuries. With its enormous size and intense radiation, it presents unique challenges and opportunities for exploration. A number of missions have been launched to explore Jupiter and its moons, and more are on the way. These missions will employ advanced technology and scientific instruments to unlock the mysteries of Jupiter and potentially discover new worlds and signs of life beyond our solar system. One of the most exciting upcoming missions to Jupiter is the European Space Agency's Jupiter Icy Moons Explorer, JUICE. JUICE will spend several years studying Jupiter and its icy moons, including Europa, Ganymede, and Callisto. JUICE will use a suite of scientific instruments to study the composition, geology, and potential habitability of these moons, and to search for signs of life. Another mission to Jupiter is NASA's Europa Clipper. The Europa Clipper will conduct a detailed study of Europa, known for having the highest potential for extraterrestrial life among all celestial bodies in our solar system, apart from Earth. As part of the mission, a high-resolution camera and a radar system will be used to study the Moon's surface and subsurface, as well as to search for signs of life in its subsurface ocean. More possibilities for Jupiter exploration is the potential for terraforming its moons. Europa, for example, has an enormous subsurface ocean that could potentially be accessed and utilized for human habitation. Scientists have proposed various methods for accessing and utilizing this resource, including drilling through the Moon's icy surface and using geothermal energy to create habitable environments. While terraforming Jupiter's moons is still a distant possibility, the potential for finding new discoveries and unlocking the secrets of these worlds is an exciting prospect for future exploration. Jupiter has been known to humans for thousands of years and was first mentioned in recorded literature during the Babylonian Empire. The planet was named after the Roman god Jupiter, who was the king of the gods and the god of the sky and thunder. In ancient times, Jupiter was associated with various myths and legends, and its movements were often interpreted as omens or portents. In modern times, Jupiter has been the subject of extensive scientific research, with numerous spacecraft missions sent to study the planet and its moons. Jupiter's shield theory, also known as the Grand Tack model, was a widely accepted theory among scientists that suggested Jupiter acted as a shield for the inner solar system by redirecting asteroids and comets that could potentially impact Earth. The theory suggested that Jupiter migrated towards the Sun during the early stages of the solar system's formation and then moved back outwards, capturing and flinging away many of the dangerous space rocks that could have posed a threat to the inner planets. However, new evidence has emerged that challenges this theory. Recent studies have shown that Jupiter may not be the protective shield that scientists once believed it to be. Instead, Jupiter may be just as likely to capture objects as it is to fling them away. It suggests that the planet's gravitational influence may actually increase the risk of some objects hitting Earth. This research suggests that while Jupiter does indeed capture many of the comets coming from outside the solar system, it may also be responsible for flinging some towards Earth. According to a study published in the Nature journal, simulations showed that Jupiter's gravity can sometimes cause comets to get trapped in a dangerous orbit that brings them closer to Earth. This means that Jupiter may not always act as a protective shield for Earth, and that some comets may actually pose a greater threat to our planet. Scientists estimate that Jupiter may capture as many as 60% of the comets that enter the inner solar system. Jupiter's role as a friend to Earth is further supported by the fact that the planet's gravity also helps maintain the stability of the inner solar system. Jupiter's massive size and gravitational pull help keep the orbits of the inner planets stable, preventing them from crossing paths and potentially colliding with each other. Recently, NASA's Juno probe, which has been orbiting Jupiter since 2016, has provided new insights into the gas giant's magnetic field and atmosphere. The probe's latest findings include the discovery that the Great Blue Spot, a magnetic anomaly on Jupiter, is moving eastward and being pulled apart by the planet's zonal winds. This is significant because the Great Blue Spot is a marker for measuring the rotation of the planet, so its movement provides important information about Jupiter's overall rotation and how it changes over time. The Great Blue Spot is a region on Jupiter where the magnetic field is stronger than the surrounding area. It was first observed by NASA's Voyager spacecraft in the 1980s and has been monitored by subsequent missions, including Juno. The new magnetic field map created by Juno shows that the spot has drifted by about 0.07 degrees of longitude per year since its discovery. This may not seem like much, but it is a significant shift given that the spot is over 10,000 miles wide. Juno's data also has revealed that Jupiter's equatorial region contains 3 times as much water as the Sun. This is surprising because scientists had previously thought that Jupiter's atmosphere was too hot to retain water. However, the presence of water in the equatorial region suggests that it is replenished from deeper within the planet, which has significant implications for our understanding of Jupiter's internal structure and how it formed. Another intriguing discovery made by Juno is the presence of giant cyclones arranged in geometric patterns at Jupiter's poles. These cyclones are similar in size to Earth, with some measuring over 870 miles wide. They are arranged in a polygonal shape, with 8 cyclones surrounding a central one at the North Pole and 5 at the South Pole. This pattern has never been seen on any other planet in our solar system. The geometry of the cyclones is thought to be due to Jupiter's strong winds and the Coriolis effect. This causes fluids to rotate in a particular direction depending on their latitude. With gusts exceeding 400 miles per hour, Jupiter's winds are among the strongest in our solar system. The formation of the cyclones and their arrangement in geometric patterns suggests that Jupiter's atmosphere is much more complex than previously thought. Super exoplanets are planets that are larger than Jupiter, the largest planet in our solar system. Often these planets are referred to as super-Jupiters, or Jupiter-like planets. They orbit stars outside our solar system, known as exoplanets. Thousands of exoplanets have been discovered since 1995, when the first exoplanet was discovered. In comparison with Earth, many of these planets are small and rocky, while others are much bigger and more massive, such as Jupiter. However, a small subset of these exoplanets are much larger than Jupiter and are classified as super exoplanets. Methuselah, also known as PSRB 1620-26b, is one of the most well-known super exoplanets. This planet is located approximately 12,400 light-years from Earth in a triple star system. It was discovered in 2003 and is estimated to be around 13.5 times the mass of Jupiter.